Oh, welcome back. Thank you for joining. And in this set of exercises, we'll look into converting entire radicals into mixed radicals. Entire radicals are radical numbers that have a coefficient of either plus or minus 1. Mixed radicals are radicals that are part radical and part regular per se. So they have a coefficient that can be different than one or a term in front of a radical. So let's take a look at the strategy or the set of steps that we discussed in class. So whenever we convert an entire radical into mixed, step number 1 would be to identify the index. So step 2 is to divide the radicand by the perfect power of the index, because we know that we can only take out the perfect power of the index. Say, for example, nth root of a to the power of n can come outside the radical, and that's our goal here. And then we can use this formula to express it in mixed form. So let's take a look at the first example. So first we identify the index. The index is 2, which means that we can break the number 27 down into factors, and one of them has to be a perfect power of 2 for it to come out. So we're going to rewrite this as the square root of. So we're looking at number 27. We need perfect powers of 2 or perfect powers of the index. So what are the perfect powers of 2? Well, 1 to the power of 2 is 1, but 1 doesn't really count as a factor. It doesn't make this smaller. So 2 to the power 2 is 4, but 27 is not divisible by 4, which means 4 is not a factor of 27. 3 to the power of 2 is equal to 9. So 9 is a perfect power of 2. And 9 is a factor of 27. So we're going to say that we need to break 27 down into a 9, and the other factor has to be 3. So you find it by simply dividing 27 by 9, and you get 3. So now that we know we have a perfect power of 2, then we're going to rewrite this as the square root of 3 squared times 3, or the square root of 3 squared times the square root of 3. Square root of 3 squared is 3, so 3 root 3 is the mixed version of this radical number. Let's move on to the next question. We have number 98. So index is 2. So that means we're looking for factors of 98 that are perfect powers of 2. So perfect powers of 2 are 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared is 16, but that's not a factor of 98. 5 squared is 25, that's definitely not a factor of 98. 6 squared equals 36, it's not a factor of 98, and always you can check if it is a factor by dividing 98 by whatever perfect power you're getting here. 7 squared is 49, so if you divide 98 by 49, you get 2, which means 49 is a perfect power and a factor of 98. So we'll write 98 now as 49 times 2. So index 2. Or if you want to write it in power form so you can show the work in here, that would be equal to 7 squared times 2. So that equals the square root of 7 squared times the square root of 2. So square root of 7 squared, these two simplify. We don't have to write the index 2 as always, but I'm trying to show this how that simplifies. So that would be 7 square root of 2. That's a mixed radical. Let's continue with number 288. So again, keep the perfect powers of 2 and all the perfect powers handy so that it makes it easy for you to identify the factors of the radicands that you're working with. So index is 2. that means that we need a perfect power of 2. So we have 1 squared, which doesn't count, and then we have 2 squared, which is 4 again, 3 squared, 4 squared. So because this is a big number, you probably want to look into the bigger powers. So in this case, we see that 288 is double of 144. 144 is one of the perfect powers. So 144 powers of 2. So that would be 144 times 2 square rooted. So that would be equal to the square root of 144 is 12 squared. And that we can split this up. We have 12 squared and 2. Remember, index 2 will simplify to give just 12. 12 root 2 is the answer. So moving on to number 75. So again, index is 2. So we're working with perfect powers of 2. So whenever the number ends with a 5, or we have to try basis of 5. So 5 squared, 25. 25 is a factor of 75, and 25 is a perfect power of 2. So we're going to rewrite this as the square root of 25 times 2. Times 3. Goodness. So that would be equal to the square root of 5 squared times 3. And that would be equal to square root of 5 squared, square root of 3. So indices will simplify to give the number 5 root of 3. So square root of 200, index 2. So we're looking for perfect powers of 2. It's probably kind of obvious in here. We're playing with number 100, which is perfect power with base 10, and then times 2 here. So perfect power of 2. So here we go. We have the square root of 10 squared times the square root of 2. So that would be 10 root 2. Next, we have the third root of negative 27. So index is 3. So we're looking for perfect powers of 3. So we have 1 to the power 3, 2 to the power 3, 3 to the power of 3, and stop right there because here it is. And we're going to rewrite this as the third root of negative 3 to the power of 3. So the answer is negative 3 because these two will simplify. The third root of negative 128. So perfect powers of 3. So let's think about it. So 128. So I'm going to take half of it actually. So you see that that would be equal to 64. And 64 is a perfect power of 3, right? And we're going to say that in this case, we'll have the third root of maybe a 64 negative times 2. And that would be equal to the third root of negative 4 to the power of 3 times 2, or third root of negative 4 power 3 times third root of 2. So that would be equal to negative 4 root of 2 index 3. So negative 4 third root of 2. Fourth root of 48. So we're playing with powers of 4. Perfect powers of 4. 2 to the power of 4. That's 16. Wait a second. 16 is a factor of 48. So I think we hit a jackpot here. So we have index 4. 16 times 3, which makes this the fourth root of 2 to the power of 4 times 3, or the fourth root of 2 to the power 4, fourth root of 3. Fourth root of 2 to the power 4 is equal to 2, and then square